Welcome to video lecture number 6, the last lecture of our unit on atoms. Last time we talked about how valence electrons determine an atom's reactivity. The closer an atom is to having a full valence shell of electrons, the more reactive it is. What I want to do today is take a closer look at how chemical bonds form. Take a moment to pause the video and write the essential question at the top of your Cornell notes. We ended our last discussion by examining two examples, an atom of sodium and an atom of chlorine. But we didn't really connect the two examples, although you may have figured out how they're connected already. Remember that we determined sodium is a metal with one valence electron, and it is reactive because it wants to get rid of that valence electron so it can become stable and happy with a full valence shell of 8 electrons. Chlorine, on the other hand, was a nonmetal with 7 valence electrons, and it really wanted to gain a valence electron to become stable and happy by filling its valence shell. If these two atoms came into contact, chlorine would take sodium's valence electron, stabilizing both atoms. In the process of losing an electron, sodium becomes a positive ion with a net charge of +1, and chlorine, because it gains an electron, becomes a negative ion with a net charge of -1. Remember that opposite electrical charges attract each other. These two ions, sodium and chlorine, get pulled together because of their charges. This is called an ionic bond because it's a chemical bond between two ions. Ionic bonds form between metals and nonmetals. The metals always give electrons away, and the nonmetals always take electrons to become stable. So the metal is always the positive ion, and the nonmetal is the negative ion in an ionic bond. Now the cool thing is that when these two atoms exchange electrons and get pulled together, they make a completely new substance. Look at these pictures at the bottom of the slide. Sodium is a really shiny metal. It has lots of luster, we say in science. And it's so soft that you can cut it with a knife, like a piece of butter. And chlorine is a poisonous green gas. But when atoms of these two elements combine with ionic bonds in a pretty spectacular chemical reaction, what do you get? Sodium chloride. Ordinary table salt that you can put on your dinner. The physical properties of salt are completely different than the properties of the elements that it's made up of. And all because one valence electron was exchanged between the atoms. That's pretty cool. Now, sodium and chlorine are super reactive because they're both super close to having a full valence shell. They're one electron away from having 8 electrons in that outermost energy level. Almost all of the elements on the periodic table are reactive, but most aren't as close to having a complete valence shell. Remember, ionic bonds only form between metals and nonmetals, but nonmetals will react with each other too. However, instead of taking or giving electrons, when a nonmetal reacts with another nonmetal, they share electrons. The atoms actually merge their valence shells so that each atom achieves a full valence shell. It's called a covalent bond. The prefix co means together. So covalent literally means the valence energy levels of the atoms are stuck together. Remember our Mickey Mouse water molecule? If we could magnify the oxygen and hydrogen atoms that it's made out of so that we can see their electron structure, this is what it would look like. All 3 atoms were unstable before they bonded together. Each hydrogen atom needed 1 electron to fill up that first energy level with 2 valence electrons. And oxygen, which has 6 valence electrons, needed 2 more valence electrons to satisfy the octet rule, to fill up its outer level with 8. That's why oxygen bonds with two hydrogen atoms. It's H2O, not HO, because for all three atoms to be chemically stable, to have a full valence shell, oxygen needs to share electrons with two hydrogen atoms, one valence electron from each. And again, the cool thing is that the exchange of electrons, the sharing of electrons in covalent bonds, and the formation of chemical bonds creates a new substance altogether. Instead of explosive gases, hydrogen and oxygen, we get a liquid that sustains all the Earth's life.